Hello everyone, I hope you had a great week. Today we're here to continue with what we were doing last week. So let's get to it. Exercise 17. Consider the rectangle shown. Okay. We just using the statement in the table, complete the sentence below to determine whether the rectangles are similar. Okay, rectangle ABCD is or is not similar to rectangle because rectangle ABCD space dilated to fit exactly a rectangle figure S. So first, and to know if two rectangles are similar, we need to calculate the ratio of the side. So as you can see, let's see, 6, like the long side over the long side will be 6/4. It has to be equal to 4/2. Now 6/4, we can divide both by 2. 6 divided by 2, 3. 4 divided by 2, 2. Down. 4 divided by 2 is 2. And as you can see, they are not equal. So they are not similar to each other. So it's not similar because their corresponding sides are not proportional. If the sides are not proportional, they cannot be similar. So rectangle ABCD cannot be dilated to fit exactly into PQRS. Now, 18. Based on the information given below, which of the following congruence theorems can be used to prove that L goes with J, well, whatever, LMN congruent to JKN. Okay, you can see more or less. Now let's see. Here we have a side. Here we have a side. Here we have an angle. Here we have an angle. Here we have a side. Here we have a side. I think it's pretty clear that is side angle side. You just need to label what you have. Also, wait. It says select all that apply. There is another one that can work. Here we have also an angle. Here we have also an angle. I didn't say it before. Sorry about that. So we have ASA, which is angle, side angle. And we have another one. We have the hypotenuse here. We have a 90 degrees angle here. We have the hypotenuse, which is gonna be this one. Okay, let me delete this. I'm gonna just write it here. This is the hypotenuse. This is the leg. And this is the angle. So we can use the hypotenuse leg theorem as well. Now let's see here. In the diagram below, ABCD, of ABCD, D, and E are the midpoints of AB and AC. And the E is drawn. Which method could be used to prove that ABCD is similar to ADE? Well, if this is the midpoint from this point and the midpoint from this point, it means that this side is, let's say this whole is 1. So this side will be 0.5. If this thing completely 2, then this side will be 1. And if this side here will be 3, then this will be 1.5 because will be also half of this. So we can say the ratio, we can use S because we can find the ratio of all the sides. Now we can also have proof this angle is equal because is the same angle for both triangles. So we can say this side, and the angle. So it will be 2 and 3. We cannot prove AA because we need the lines to be parallel to each other. So this could be something like this, and the sides might not be parallel to each other. So yeah, that's the reason. Now in the figure QP, QPT and STP, QPT, STP, okay, are right angles. Okay, so this is a right angle, and this is a right angle. Sides PQ and ST are congruent. Which statement is always true? Are S congruent to PQ? No, that's not even. That's basically very rare even to cure. No. Are S congruent to RQ? Maybe. Are S congruent to RT? No, it is not necessarily. PS congruent to PT? No, that's not even possible because it's a right triangle. So this square plus this square needs to be equal to this square. So not even possible. So yeah, these sides are gonna be corresponding to each other. So this is going to be corresponding to this, and okay, I was just looking at something. Okay, yeah. Because this whole thing is going to be corresponding to this whole thing as well, and then this little thing will be corresponding to this little thing as well, like the little part. So the top two with the top, the bottom with the bottom, and complete to each other. That's basically what it happens. Oops. Better. Now, the elementary school in your town wants to replace its current playground. The space used for the new playground will be similar to the current playground. The current space is rectangular. Okay. Okay, it's a rectangle. It has a length of 18 feet and a width of 15. The length of the new. Okay. This is gonna be the new playground. The length of the new playground is 30. Find the perimeter of the space used for the new playground. So it is similar, so we can establish a ratio. So it could be 30, the length over the length, which is 18, is going to be equal to the width of the big one, we don't have it, to the width of the small one, which is 15. So if we can cross multiply, 30 times 15, 30 times 15 for 50. So 450 equal 18x. So I divide both sides by 18 and I get 25. 25 equal x. So the width will be 25. Now, we are looking for the perimeter. So we know rectangles opposite sides are going to be equal to each other. So this will be 25 plus 25 plus 30, which is 110, which is option D. Now, 22. Quadrilateral ACDG, so A is similar to QYWT. So A goes with Q, C with Y, T with W, and G with T. Now find the value of X. They want to find the value of x, so we can say x plus 5 is going to be equivalent to what? So it's red, purple, and red, purple is 20, 20. Then the other one we have in this side is going to be 5, so it's equal 5 to which one? Which is purple to blue, and purple to blue here is 4, so 5 over 4. We cross multiply, we say 4 x plus 5 equal 20 times 5 is 100. Now we divide both sides by 4. This cancels out. 100 divided by 4 is just 25. And then we subtract 25 from both sides and we get that x equal 5. Which is not of the options, and I think oh wait, never mind. That was my bad. 5 times 20 is 100 divided by 4. Wait, 20 as 5. Wait, let me just make sure I establish the right angle. Yeah, it goes with Q. C goes with Y. D, W, G, T. And I say 20 to 8 over 5 to 20 is 5 is to 4. Oh, I got it. I'm just sometime dumb. Sorry. So yeah. We should start 5 from each side. I got it right at the beginning. And this x is gonna be equal 20. I don't know why I said 5. I was dividing. I'm sorry. So yep, our answer is 20. Yep. So let's continue. The following statements describe triangles ABC and PQR. Okay, we don't have the triangle, so let's draw them. This is A, B, C, and this right here. Wait, better. This is PQR. Now we know that AC. Wait, let me. QR equals 7.5. PR3 and PQ6, and then here AC2, AB4, BZ5. So this is what we have. Now, which statement explain why ABC and PQR are or not similar? So let's see. I'm gonna say the big one of this 5 over the big one of the other 7.5. It has to be equal to the big one of like the middle one here, which is 4. The middle one here, which is 6. And then the small one, which is 2 to 3. Now if I divide 5, well, if I divide this by by 2.5, like 5 divided by 2.5, 5 divided by 2.5, that's 2. So I get 2. Now 7.5 divided by 2.5 is 3. Now if I divide this by 2, 4 divided by 2 is 2. 6 divided by 2 is 3. So as you can see, they are all equal to 2 over 3. So they are similar, they have the same ratio. And here, let's see, let's see which one is true. So we can discard C because it has only two options. We need the three, and A because they're saying they are not similar. Now we need to identify if they are identifying the size correctly. So AC is a 2 goes to PR. So AC goes to PR. Now PQ, why PQ? We are starting with this. This is the thing. See? Here they are putting at the top the other triangle. We cannot do that. We need to keep one triangle at the top and the other at the bottom. So no. So answer is this. You have AC from the blue triangle is to PR from the purple, and then BC for the blue is to QR from the purple, and then AB from the blue is to PQ to purple. It's always from one triangle to the other. So this is our answer. Now 24. A part of a sandbox in the shape of a quadrilateral. A part has a sandbox of a shape in a shape of a quadrilateral. Christian wants to create a smaller sandbox at his backyard, using the same angles as the part as shown. What is the perimeter of fit of Christian sandbox? So we have this. We can say that there is, I'm gonna say this is X. You know, these two are equal, so this is also going to be X. It has to be equal. And then this is Y. So I can say that X is 18 is to 18 as 8 is a 36. So I can cross multiply and I get that 36x equal 18 times 8. 18 times 8, which is 144. So 144. And if I divide both sides by 36, I get that x equals 4. So this is going to be equal 4. And then y, I can say that y is 27 is to 27 as 8 is to 36. So more or less the same. So 36y is going to be equal 27 times 8. 27 times 8, which is 216. And if I divide by 36, I think it's gonna be like 16, something like that. Yep. Going to be equal 6. So here we have our values. So this is going to be, whoa, sorry about that. Yep. So this is going to be equal 3. 3 was it? Wait, 4. So 4, 6, and 4. If I looking for the perimeter, as the question says. What is the question? Oh, yeah. What is the perimeter? So I'm just gonna say 4 plus 6, 10, plus 4, 14, plus 4, 8, 22. So 22 feet. Now let's see, 25. So partial proof is given using isosceles triangle ABC. Okay, ABC is an isosceles triangle where angles B is the vertex angle. So if this is the vertex angle, this means these two are the base. So this is the base angle, and this side must be equal to each other because of the isosceles theorem. The two sides of the triangle are similar, like are equal to each other. Now we're also given that BD bisects ABC. So if BD bisects ABC, the angle, this angle is going to be equal to this angle. No. The statements given, given, given. So we're looking to prove that we're using the side angle side theorem. So to use that, we either need to prove we have this side, we have angle here, and angle here. We either need to prove this side or this side. They both will work. So let's see. Angle, we do not need angle, and we do not need angle. We're looking for the side, angle side. Now, AD equal to DC. Okay, that's true, but we are not talking about midpoint. That's the thing. We are not saying anything about midpoint here. So we cannot say that. On the other hand, we can say that BD equals to BD because of the reflexive property. It's the same line, so it has to be equal. So, yep, this is our answer. Now, 26, segments A, C, and BD are diagonals of parallelogram. Using that AD is congruent equal to BC, which pair of angles must be congruent to prove AED is congruent to ACB. Okay, we have this side. At this side, we're trying to prove for AED, and we have one triangle to prove by CECEB. So these are the two we are trying to prove. So we have this side. If we have one side and they're saying that we need angles, then, oops. Okay, whatever. We need to look to this. We only have one side, and the only theorem for congruency that only has one side is angle side angle. Oops. So we need to look for the two angles adjacent to the line, which will be A, D here, B, and C. So let's see. B, C, A, yes, that's one. To which one? B, D, A. Okay, this will work. One of the ones we need to prove. Then do we have another one saying CB? Okay, D, B, C. Going to B, D, A. Okay, now that's could work as well. D, B, C, and B, D, A. That will work, but they are diagonal now, so it wouldn't work with the ones that we selected. So I'm gonna say in blue. Now, D, okay, which is going to be this one, this one. Now, DAC, DAC, okay, to DBC. Okay, now, look, DAC, which is this, to DVC, which is this. We have our two purple. Let's see if we can find another blue. So we're looking for CAD. So CAD, nice. To nice. To BCA, nice. This is our other blue. And then BEC, congruent to AED. Okay, yeah, well, they are congruent but it is not important to know the angle side angle theorem. So now we have for two pairs. I might have committed a mistake somewhere. That's what we got. So 27. A partial proof is given. Two statements are missing. Now, statement 1, AV over AD. So AV over AD is equal to AE. Okay, I cannot see that. So AE to AC. And let me put the the blue one here. Okay, yeah, better. Now, point A, B, C are collinear. Points A, E, D are collinear. Okay, fine. Now we'll be statement 2. Okay, angle 2. Okay, we're looking to what? Okay, we're looking to prove that one angle, 1 congruent to angle 4. So what will be statement 2? We have proportionality. We would like to prove. So we have a side. Let's look at this. We are looking for similarity. We have the proportionality of a side here and a side here. So we have two sides. So for the blue thing is side here, and here will be side, side. So what are we missing? We're missing the angle in the middle, which is angle A. So we want to prove that angle A is equal. So we can prove that the two triangles are similar. Now, which triangle? We have the big line, which is C, A, D is the big line C, based on the big line on the light blue big line. C, A, D. So C, A, D. Or well, let me just try to see the order here. So A, B, E. So it will be A, B, E. So we have this right here, A, B, E, which will be blue, dark blue, light blue, and A, C, D, A, C, D. And as you can see, no, because it is inverted. We did it in a different order. Now, E, A, B. So E, A, B, light blue, dark blue, C, A, D, C, A, D, light blue, dark blue. So this is what we're looking on our third statement. We are looking at the same order here, so that's our answer. Now 28. In quadrilateral ABCD, AB like is congruent to CD and BC is congruent to AD as shown. So it's already there. So set a term from table to complete each proof, like each part that proves that triangle ABC congruent to triangle CDA. Okay, so by the okay, well, let's see. We have side, 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 side. What can we say? A way to make it like to prove it that it's pretty easy. And I think that's the reason that this line is here. This is the same line for both triangle. So it makes an S. We can say side, side, side is the same line for both triangle. So I will say that by the what's the property that allows us to say that's equal is the reflexive property. It reflects over itself. So by the reflexive property of congruency, so reflexive, we can show that AC is congruent to CA. AC is the same line. So it has to be congruent with itself. So triangle ABC is congruent to triangle CDA by the side, side, side theorem. And that's it. Now let's continue. A partial proof is given. For each blank, select a reason from the reason bank to complete the proof. So let's see. We have that these lines are perpendicular. We want to say that this angle, the angle formed by those lines, which is this and this, are perpendicular. Why? Because of the definition of perpendicular lines. Since perpendicular lines create right triangles. So, definition of perpendicular lines. Now, oops, wait, I'm trying to. We want to say that J JPQ JPQ is congruent to NOM. So the two right triangles are congruent to each other. Yes, because they are right triangles. Right angles, I mean. So yep. Because all right triangles are congruent. Right angles, I mean. I'm sorry about that. So all right angles are congruent. So all right angles are congruent. Then we are given that these angles are okay, this is what we're given to. We have that, and we're given that J congruent to N, and we're also given that AP congruent to MO. Now, and okay, yep. So this is all we're given. Now we want to prove that JK, yep, JPK is congruent to NOM by the angle. Wait, you see here, we have here an angle. Wait, another color. Yep. Angle, angle, side here, angle here, angle here, side here. So it's by the angle, side theorem. And then we can prove those two are equal by seeing congruent pair of congruent triangles are congruent. So CPCT. C. Now 30. I think this is the last one I'm gonna. Oh, no way. I'm gonna finish. So, 30. The temple of Kukulkan is one of the tallest and most remarkable examples of the Mayan architecture. So, Fabio wants to build a smaller wooden version, keeping the head's length and width proportional to the angles and the angles congruent, obviously. A sample drawing but structures below. So I want to find x and I want to find y. So first, let me do something. I want that one. If I do this, so I can make it better, it will be the same as this. So we can get the length, this length right here by saying 30 minus 6. This is going to be 24. And I'm gonna use that later. So this right here, this right here, this is 24. Now, so let's see. We want to solve for x. We can say that x is to 24 that we just calculated as the base, we do have it here, 4.6, is to the original base, which is 55.3. So go to the side. We cross multiply 55.3x equal 24 times 4.6. So 24 times 4.6 is 110.4. So 110.4 if we divide by 55.3 in both sides, we get 1.996. We have to round it to nearest tenth. but the nearest tenth, nearest tenth is this number right here, the first 9, but we have a 9 after. So it will add up to 10 and it will add up here, so it will be just 2.0, which is, so x approximately 2.0. Then let's solve for y. So x approximately 2.0, and then y, use purple now. We can say y is to 1.12. We do have it here as this base, the base of the big one, 55.3 is to 4.6. So we cross multiplies and we have 4.6y equal 1.12 times 55.3, which is 61,936. So 0.6, right? So 61 point, wait, I forgot now, 936. Now I divide both sides by 4.6. So I divide by 4.6, and I get up, we are rounding to the nearest tenth. So this is a 6, so we add up to the first one, which is gonna be 13.5. So 13.5. And those are our answers. And now let's go to the last one. And we're starting a new unit next week. Or I don't know if next week, since it is spring break. But we might have a session. I'm not sure though. So let's see. Your town wants to expand the community dog park with one similar in shape to the current dog park. The current dog park is rectangular. Okay. Rectangular. Have a length of 75 feet and a width of 60 feet. Now the length of the new, let's do the new. The new dog park is 100 feet. Find the area of the new dog park. First, we need the width. We do not have it. So I can say that this width, the width of the big one, the new one, the width of the new one is 2. The width of the old one, as the length of the new one is 2 the length of the old one. So we cross multiply. I got 75x equal 6,000. So we divide 6,000 by 75, and it is 80. So x equal 80. And if we are looking to find the area is just one time the other. So it will be 100 times 80, which is just 8,000. And that's option C. And yeah, that has been all. I'll see you guys next week or the other with new content. Bye.